Alright, hello boys. Welcome back to school after y'all have been taking your break for so long. Sorry, I needed the yawn. Okay, so chapter 3 is about functions and graphing lines, etc., etc. In 3.4, just to recap, we learned about slope-intercept form. What does that mean? Slope-intercept form. Slope-intercept form is a way of drawing an equation of a line so that it shows us the slope and the intercept, slope-intercept form. Remember, the slope tells us how much up and over we're going when we go from point to point on a line, and the intercept tells us where we cross the y-axis at. So in the case of y equals 2x plus 1, we usually like to start with the intercept. Plus 1 tells us we cross the y-axis at plus 1 right here, and the 2 tells us that we turn it into, think of it as a fraction, 2 over 1. 2 over 1 tells us we go up 2 and over 1 in order to find the next point. Up 2 over 1, there's our next point. Up 2 over 1, there's our next point, and it also works the other way. Down to left 1, there's a point. Down to left 1, there's a point. Down to left 1, there's a point. If we connect all these dots, that's a line. It's the line 2x plus 1. So slope-intercept form gives us the slope and the intercept. This lesson, 3.5, is point-slope form. Now, point-slope form is a way of writing down your equation of the line. I shouldn't have deleted that. Hold on. So point-slope form is just another equation to write the same line. So slope-intercept, there's our slope, there's our intercept, and then point-slope is over here. So notice it's a little different. What's the same, what's different? Well, what's the same is that we got a y, we got a y, we got an m, the m is the slope, we got an m, and we got an x, and we got an x. Now what's different? Different is we got this little y subscript 1 and x subscript 1, which we can just call y1, x1. Now, what do these two things represent? Those, as you might guess, represent the points. So remember, this is point-slope form. These are our points. This is our slope. So let me show you what we mean. So if we know that our line has a slope of 2, and one of the points on the line is 2, 5. Remember, for coordinates, this represents the x value, that represents the y value. So what we're just going to do is we're going to rewrite this point-slope equation and just substitute our new points. So y minus, what's our y value? Our y value is 5. Okay, we said our slope was 2. X minus, what's our x value? Our x is right here, 2. So that you might be saying, this is even more confusing. What the heck? Well, let's go ahead and simplify. Can we simplify anything on the left? No. We can just rewrite that. On the right, what can we do? We can distribute that 2 through. 2 times x is 2x. 2 times negative 2 is negative 4. And remember, for lines, we want to get y by itself, or equations of lines, we want to get y by itself. So to get y by itself, all we got to do is add 5 plus 5 plus 5. That gives us y equals 2x plus 1. So we see that, these two lines are the same. Now, how does this help us? So let's say I want you to graph a line. If I tell you it has a slope of 2 and an intercept of 1, well, you just go and use this equation and you substitute your slope with a 2 and you intercept with 1 and you get the equation of the line right there. But what if I don't know the intercept? What if I only know the slope, and the other thing I know is that I just know one of the points. I know the slope is 2. I only know one of the points is this. I don't know where I don't know where the intercept is. Well, that's fine. You can just use this equation and just plug it in, simplify, and you'll get the exact same thing. So the reason we have different equations is for different information. Depending on the information we have, that's the equation we're gonna use. All right, let's take another example. On page 111, example 3.5c, it says find the equation of a line with slope m. So our slope m equals 2, so we know that m equals 2, and for a point, -1, 3, -1, 3. So with a point, -1, 3, we don't know where the intercept is, so we can't use our point slope, we can't use our slope-intercept equation, but we do have our point slope form. Y minus y1 equals the slope times x minus x1. So all we got to do, let's replace that m with a 2 and replace our x with our x and our y1 with our y. So what do we get? Well, this y doesn't change. Our y1 is 3. Remember, whenever we substitute, use parentheses. M is 2, slope of 2. X minus x1 is -1. Don't forget those parentheses or else you'll screw up your negatives. All right, can we simplify the left? Yep, that's just y minus 3, drop the parentheses. On the right, let's simplify the parentheses. Inside the parentheses first, we got 2 negatives touching. 2 negatives make a positive, so we'll just rewrite everything else. 2 times x plus 1. And now we can distribute that 2. 2 times x is 2x, and 2 times 1 is 2. And now to get y by itself, we just add 3 to both sides. And now we get y equals 2x plus 5. And now we know how to graph this. It's in slope-intercept form now, so we just graph our intercept at plus 5. We'll just go ahead and use the normal hash marks, and then we have a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, and then keep going and keep going. All right, question 3.5D on page 112. The information it gives us is we have a slope of -5 over 2, and it passes through the point 2, 1. Now, we want to be able to graph it, and what information do they give us? They give us a point and a slope, so we want to use point slope form again. So always rewrite point slope form. Always rewrite the beginning of your problems. We don't want to mess up with the source material. So substitute our, so we got y minus y1. y1 is 1. Notice how for all these we're keeping the negative in place. That's because when we're substituting, we're just substituting our variable. We don't care what's in front of it. We're just substituting the letter part. So y minus y1 equals m is -5 over 2. And then we got regular x, and then x1 is 2. All right, simplify the left, y minus 1, just drop those parentheses. On the right, we can't simplify. Oh, we go straight to distribution. So -5 over 2 times x will just give us -5 over 2x, and then -5 over 2 times -2. The negatives cancel, we're just left with 5 over 2 times 2, which just gives us, the denominator will cancel out, and that will give us +5. And now to get y by itself, we just add a 1 to each side. That'll give us y equals -5 over 2x plus 6. And now we can go ahead and graph it because we see we got slope-intercept form. Our intercept is +6, so we'll go to 6 right here. And what does the slope tell us? It means we go down 5, right 2. So 1, 2, 3, 4, 5, right 2, 1, 2. 1, 2, 3, 4, 5, right 2, 1, 2, and so on, and that's our line. Okay, one last example, 3.5e. Is it one last example? Yeah. Okay. It says, find the equation of a line that passes through points 2, 1, and 4, 5. So they go ahead and just give us 2 points. Now, it's probably a while since we've last done a problem like this. So we have points 2, 1, 2, 1. We'll go ahead and count by, yeah, whatever. 2, 1, and 4, -5, right here. Okay, so obviously we've already graphed it, and we could just draw a line through here, but we want the equation of the line. So, do you remember how we do this? Do you remember the equation for finding the slope? It was m, y value 2 minus y value 1 over x value 2 minus x value 1. And all this means is that we got one pair of coordinates right here and one pair of coordinates right here. And if we substitute everything, that'll give us our slope. So let's call these our, it doesn't matter which ones are first and last as long as we just pair them up this way. So our first y is 1, so let's go ahead and substitute. Our second y is negative 5, so we'll substitute. Put it over the x's. Our first x is 2, so we'll substitute. And our second x is 4, so we'll substitute. And now we just simplify. 1 minus negative 5 minus negative 5 is the same as plus 5. So that just gives us 1 plus 5 is 6. Equals 6 over, and 2 minus 4 gives us negative 2. 6 over negative 2, 6 divided by 2 is 3, and the negative makes it negative 3. M equals negative 3. So we know our slope is 3. Now, how do we get the equation for the line? Well, we have a slope. What else do we have? We have a point. So let's use point slope form again. So we always start by rewriting point slope form. Y minus y1 equals m times x minus x1. And now we just substitute one of our coordinates. It doesn't matter which one's which, as long as we put them in the right order. Our y1 is 1. Our slope is negative 3. Our x is 2. Oh, almost forgot parentheses. All right, simplify y minus 1. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Then we add a 1 to each side. That gives us y equals negative 3x plus 7. And now we know our intercept is 7. And we have a slope of down 3 over 1, down 3 over 1. Look at that, it connects down 3 over 1, down 3. I'm a little off, and I don't know why. That's okay. Oh no, I'm right. Down 3 over 1, down 3 over 1. See, they all fall in place, and this is the equation for the line. So, yeah. So there's a little table called Table B on page 112. I want you to write that little graph down in your notes for reference. But in summary, the point was just finding equations so we know how to graph lines, and we're going to be given different pieces of information. Sometimes we'll be given the slope and a point, sometimes we'll be given a slope and an intercept, sometimes we'll just be given 2 points and we got to be able to find the slope from that. So it's just a matter of turning the information we have into something useful, and that's where the different equations of lines come in. So that's all. See you in the practice video.